Okay. You ready to record, Neil?
Yeah.
Hi.
Hi, Kip. How's it going?
It's good to meet with you. Hello, friends. This gives you context. Neil Beesley and I are meeting in the midst of COVID era. We've judged that we're adequately 6 feet apart. We've been meeting like this in this room in the IBM office for a year now, which come March of 2020 was vacated. We haven't seen, we get the entire office to ourselves. We took a number of month hiatus, 3 months hiatus, but then we started meeting again on Fridays. I'm about to move from Dallas, Texas, where Neil lives, and where I've lived for nearly 10 years. Mm-hmm. And I thought it would be good to have a conversation with Neil. Is that a good summary?
That is a pretty good summary. It's been a lightning year in that sense. Maybe not a good year for in other ways, but
yeah,
as far as the progress that we've been able to make on SAFA.
Neil, why would I have a conversation with you? Why would I choose to sit down and talk with you? Can you give a little bit of your background on mainframe development and tell people who you are?
Yeah, before I started on assembler programming, I worked for Rolls-Royce Aero Engines, so there was a lot of design, but that was very different design. And I moved from there to work for a German software vendor that was very big as a mainframe software company, and they told me more or less from the interview, you're going to do everything in assembler. You might do a little bit in a 3 or 4 GL, but for the time being, you're going to have to become good at assembler. You're going to have to teach yourself. We'll help you. So from there...
No, tell me more about that, Neil. How long did they give you to do that?
Oh, it was pretty open-ended. We worked in offices of maybe 2 or 3 people.
Okay.
So you would always have someone with 10, 15 years. The office where I worked, we had a guy that had been, he wasn't much older than me, but I think he'd been programming hands-on assembler for somewhat longer than me.
Yeah.
And then I was the middle one. And then we had a third person join us called Gillian Tasker. And that's not her name anymore. She lives in Australia.
Yeah.
And she's on the SAFA team.
She's on the GenevaERS SAFA team. She is. So she was the one that recommended that we look at Neil. So you must have treated her okay. She does assembler development too. Okay, so after that, you became proficient at assembler. And what else have you done?
What I did while I was working for that software products company, German company, I got around the database and the language, the 4GL language. It was all mainframe. And then I got into the middleware and I started learning how do you connect ZOS? How do you connect a mainframe efficiently to client server?
Yeah.
To Windows, it was Unix then, but that became Linux.
Yeah, yeah.
And so I didn't stop doing it.
But you were then had to learn all the other platforms in order to talk to the mainframe.
Yeah, so I was programming on AIX and various other platforms at that point.
Yeah.
Which is kind of I haven't done that for a long time.
No, but it's good to broaden you. It's good to have a breadth of abilities. It helps you. I found when I learned a new language that I understood English better because I'd learned a new language, and I understood the differences, and so understanding multiple platforms allows you to understand computing in a better way, in that same way.
Right, and so after that era, I did a certain amount of consulting work. Again, that was cross-platform, but a big part of that was ZOS.
Yeah.
And just learning other things there, language environment, Unix system services.
So, okay, now let's recap this last year. Let's jump forward now.
Yeah.
Okay. Coming into the GenevaERS project, SAFR, you didn't know anything about it. I mean, there's a Wikipedia page maybe you read before the
yes, but I did make a few phone calls to Jill to see what I was getting myself into.
But now tell us, a year into it, what's your impressions? What about the tool? Why are you enjoying working on the project and the software and the open source team?
Well, it's the product's come about over a number of years of solving the problem of how to process data efficiently, lots of data very efficiently. So the way that it can process large volumes and do billions of lookups efficiently.
Yeah.
There's a lot of engineering, a lot of software engineering that's gone in. So I'm learning. There's obviously a lot there to learn, but that itself is, it's nice to have a product that has got that level of design sophistication in it.
Well, okay, so the thought you trigger there, right? I've been part of the GenevaERS team since very early on, not the beginning of the product, but when it became a commercialized product. That engineering is something that has evolved slowly, but on each project there was something that added to the capability of the engineering involved, and that got added on it, so it's an accumulation of knowledge over a very long period of time that's built up what's in the tooling.
Yeah, and you can see that from the code. It's like layers and layers. You can see, okay, well, we've come up with a whole new, better way of doing that, and you can see how that is that was engineered into the product as it stands now.
Okay, but last week you and I met. That kind of prompted me to, you're into one part of the code that's not quite so elegant right now.
Oh, well, it's getting there.
MR88. It's one of the older parts of the product. Last week you and I talked a little bit about Spark. I thought it would be helpful maybe to record a little bit of what we talked about and the relationship between GenevaERS and Spark. So, you want to describe briefly what MR88 does?
So MR88 is, well, we need to give a bigger picture than that, maybe.
Do that.
So I'll step back
Good.
and say, I won't step back too far. I'll start at the extract and reference phase. So the extract is extracting huge volumes of data, huge amounts, and the extract and reference, it means it can do lookups, billions of lookups very efficiently.
Yes.
And it can collate data together, and it produces an extract. So the format phase, which is MR88, is concerned with summarizations or summarization of the data and reporting.
And in a different vein, you might call it map reduce.
Map reduce.
I mean, map is the extract phase in a certain sense, and reduce is the summarization format phase.
So it's very different logic to take your mind from the extract, the code that deals with the extract reference phase. It's very different mindset to dealing with reduction.
Yes.
Summarization, reduction of data.
Yes, and MR88 works on the principle assuming that the data is in sorted order. It's a control break logic program, right? Looking for changes in keys to trigger certain functions to happen based upon changes of keys of the extract records. Yeah,
whether that's a total for a particular customer, for a particular week, whatever that is, whatever that break key.
And that's a different kind of a logic than the extract. The extract program doesn't assume any order of the input files. Each record is independent in the extract phase, but when it gets to format phase, order is important, isn't it?
That's correct.
So one thing that we've talked about, see the extract phase of GenevaERS, also called SAFR, the IBM product name for it was, that for years has been called SAFR. The extract phase is a parallel processing code generation engine, right? I mean, it generates machine code and executes the machine code in parallel. It's quite an elegant little design.
You could call it a virtual machine in the sense that it takes logic,
Yes.
and fits model code
Yes.
to that,
Yes.
which is that's one of the great efficiencies of SAFR, is the fact it has very optimized models.
Yes. Yes. Very good. MR88 never got quite to that level of sophistication because it's control break logic, but also the data typically got reduced down in the extract phase to the format phase, and so it just never quite got the engineering necessity, particularly if you do extract time summarization. The format phase becomes much less performant, much less important for performance. Neil and I last week, in talking about this and talking about our interaction with or our intersection with Spark, we said, you know, it could be interesting because our sense is that the map phase on Spark, Apache Spark, is fairly simple in what it does. It basically is intended, and it could do more than this, I'm sure. This is a simplification, but in the simplest sense, it really is taking the file, whatever, or set of files, whatever those are, and it's mapping them to the set of resources available to do the reduce phase. So it's really, that's its one purpose, is to break up files across nodes of a cluster to go process those. The reduce phase in Apache Spark is more sophisticated than the GenevaERS reduce phase. But the extract phase of GenevaERS is more sophisticated than the Apache Spark map phase. So we think there's an interesting intersection there where GenevaERS could be the map on the mainframe of MapReduce, where it would do more functions in that extract phase. It's not limited. It could produce hundreds of outputs in the extract phase, as opposed to a single output of simply reducing the file or breaking up the file, partitioning the file for the format for the reduce phase processes.
That's something we'd like to investigate, to take forward. If we can actually match the best of both SAFR and Spark by doing that.
So let me say one thing why Neil had been helpful to me this year. When I meet with Neil and I was explaining to him a whole bunch about GenevaERS and SAFR, when I throw out a little idea of, you know, we could ultimately do this, Neil's not one to just kind of sit around and say, yeah, we should put that on a plan and maybe someday get around to it. Neil would say, well, how do we do that? And so I found myself saying, okay, I need to follow Neil's. He's got energy here. He's helping me investigate this space more thoroughly. So I would set up every Friday, I say, Neil, can we meet in the office at 10 or 11? And I'll teach you what I know and we'll talk about stuff. But every week it would turn into, well, what can we do about that? Okay, well, I'll follow your lead.
Or should we try it?
Should we try it? And so it's been very helpful to me. Neil has been very encouraging to me to do this experimentation. I want to compliment you. I complimented him in an email this last week.
I appreciate that.
No, it was great.
You don't always get thanks for wanting to experiment.
No, but it's been very helpful because it's generated energy, and it's these insights that you're getting here about Spark, Apache Spark. I had most of that knowledge, but I hadn't articulated it in the clarity of going through it with Neil and the winnowing down of the idea more clearly through the process of experimentation. Where we didn't get to this year, which Neil's and I have worked on multiple times, is we wanted to do a simple process of calling a GenevaERS subroutine that does I/O from Apache Spark. we have a little Geneva overlapped BSAM IO routine. BSAM is the access method on the mainframe, and we've been trying to to use. We've just run into all sorts of environmental issues, right? The Unix system services setup, the need to get a compiler to be able to find the header files created out of the Java JNI process.
Yeah, stuff that we probably, if we'd been Windows programmers, we would have just got something off Google and compiled it on Windows Visual Studio, and it would have worked out of the box.
Okay, but we're working on ZOS, and so we've got not only is there less people doing this kind of experimentation out there, so you find less on the internet about these kinds of topics that you can just follow the trail that others have already blazed. You also are working against environmental issues of the machine setup, the system programmers, the tooling involved, the products involved. It's kind of stumped us a little bit.
Yeah, and an environment where people aren't conducting this type of work.
No, but this kind of work is really where innovation happens. It's unpredictable, it's difficult to do, but it's really where you get breakthroughs of ideas.
Well, we have a module. Just haven't run it yet.
Okay. So
Return code 0.
So anyone that's going to listen this far into our conversation here, we'd love to have some more help.
We did find one person.
We found one person. We're going to send him a link to this video. See, maybe he calls us up. He's got one of the websites out that talks about doing this. But we're looking for more people to join in and help us on calling assembler routines from Java directly, because we think there's some benefits that come from that. There's some performance benefits that come from that, because we can do things in assembler that will have real performance implications. But Java takes us out of having to deal with everything being an assembler.
Yeah,
We don't have to deal with a reduce.
Yes, and if we get it connected, if we start to make this kind of connection, that prototyping we're doing of calling this IO routine, then we think leads us to being able to start to integrate Apache Spark with GenevaERS functions more directly.
Yeah, I can see that coming out, possibly even in memory from MR95.
Okay, so we'll do other videos.
But that's
in the
down
future. We'll go into more detail on that. Okay, Neil. A few months ago, I don't know if you'd be willing to share this, and I can edit this out if you don't. But you shared with me the funniest mainframe story. I literally was in tears.
there's been a few.
But the one that you shared was around a company that tried to get rid of, there's an old version of the mainframe.
Oh, MVS 0.3.8. It's still available.
It's the last version of what became ZOS. MVS is the predecessor to ZOS. It's the last version that was not copyrighted by IBM. So it's available for use in, and it's free. It's open source. I mean, it's freeware. You can find it on the internet. You can find the source code, and you can find compiled versions of it, and you can run it under an emulator called Hercules. It'll be a virtual machine that runs on multiple platforms that gives you a mainframe on a platform. But sometimes when you get into mainframe, people with deep mainframe experience, you get into older stories about how, well, let me say it slightly differently. One of the things that I've done this last year is I bought a Raspberry Pi, which is a very small little machine, very small computer that was developed because people were no longer feeling comfortable to go get down and play with the machine at the hardware level to break their machine, because your computer that you use for your home, your billing, your whole finances are tied into it, your communication, your social life, so much that you don't go mess around with your own PC anymore and change basic settings in the computer that might break it. So the Raspberry Pi Foundation made this little tiny computer that's $60 so that people feel comfortable buying one of these and messing around with it, right? That sort of experimentation is important. In older days, there were mainframers who would do that kind of experimentation with a mainframe. One of the things that you talked about was that a commercial company tried to use that version as their production system, but they ran into problems with the disk drives.
Oh, yeah. Because
Can you tell us about that?
yeah, that version only supports 3350 DASD.
Those are very old.
And unfortunately, 3350s aren't available anymore.
Nobody makes 3350. I mean, you might find some in an old computer somewhere.
No, not anymore. Not even 3380s.
Oh, okay. Well, I meant if you found, like in Germany, they found a very old mainframe that was in an attic somewhere.
Yeah.
You might find one there, but it's going to be very rare to find one.
Yeah.
Okay, so what they do?
Oh, there was a way to basically, this is more at the microcode level. There was a way to make a
Let's describe microcode.
Okay.
I don't know if everyone will know what microcode is. Can you describe what microcode is? What layers?
Now we have to go into the channel.
Okay, so you have your application that you use, like Microsoft Word, right? Okay, then below that is a language that somebody wrote to make that application. Then below that, you have the operating system, which hosts the application. But the operating system, in some instances, is generalized, and in some cases, there's specific code that's written for a specific piece of hardware. For your monitor, when you put in a driver, I guess would be kind of the closest thing on a Windows system, would be the driver, would be the microcode that runs that specific piece of hardware. So they'll drive the microcode for, is it 3350s?
Yeah, the basically your I/O drivers. We managed to put something together. There's nothing can't claim credit for any of this at all. But as a company, we managed to put together, with a bit of help from overseas.
We had to find somebody, and the only person you could find was from South Africa.
We found, and we paid for him to come over and do what was needed.
Because South Africa had been going through apartheid, which meant they couldn't import anything, so they had figured out how to do these, how to save very old systems and keep them working.
Yeah, they basically knew how to re-engineer anything. So we took our 3380s and slapped software, driver, basically software on them.
This guy came and wrote microcode.
Well, he brought some, but he still had to make changes while he was here.
Right, yeah.
While he was there in the UK. And he made our 3380s look exactly like 3350s, so that we could bring up this
very old version of the operating system. But the guy only spoke.
He spoke Afrikaans, yeah. So, but we had a colleague who lived in South Africa.
There was only one other person in the company that could be his translator.
He was fluent in Afrikaans, so he got the job of spending time with him. A very, very smart guy was that came over.
I'm sure he was. Yeah. Okay. So, if you're interested in doing some experimentation with Neil, Neil's not afraid of that sort of experimentation. And then you get a sense why every time Neil, well, how do we do this? Okay,
let's try it.
Let's try it. There's nothing to be afraid of in here. Well, that's plenty of grist for the meal, I think.
Thank you.
We'll see what comes out of our conversation, what is useful to people. It's been a pleasure to meet with Neil today. Thanks for your time, and thanks for joining me on this conversation with Kip.
Thank you.